Welcome to an example where we've got 9 secant, or it's right here, 9 secant xy equals square root, and they want us to find the tangent line to the curve, which that always means y prime, which is slope. We're going to have to find slope by finding the derivative. Okay, so how do we do it? Step one, derivative of both sides. We'll take the derivative of both sides. So derivative of this side, derivative of that side. Okay. How do we do the derivative of this side? Well, you know when a number is multiplying the front of a function, it just sits there when we take the derivative. Okay. So now what's a derivative of secant? Do you remember that? Derivative of secant of x is secant of x tangent of x. That's the derivative. Derivative of secant is secant tangent. So now we understand that the rules were given in math and science. Whenever they put an x, that's just holding a spot. So that means whatever you have here, it's like if you have xy, then these guys are both going to end up xy, and that's what we have. So this will be secant xy tangent xy. That makes sense, whatever's in the argument. Now, turns out we're not done there. Why? Why aren't we done? Because this is inside. Remember, if the inside of any function is not a simple x, then the chain rule, I'm going to go times, um, and this problem is going to be big. Here, I'm going to give some more room here because I didn't realize this was getting big. So here, 9 secant xy, tangent xy, okay, times. Now, right here, the chain rule tells us if the inside function is not a simple x, and xy is not a simple x, you got to do the derivative of the inside and multiply by it. So here we go, multiply by it. Now, double trick. What is the inside? It's two functions multiplied, so we got to do product rule. Product rule. Is that making sense? The inside tells us we have to take the derivative of it. That's what the chain rule says. And to take the derivative of xy is going to involve chain rule because there's two, I'm sorry, is going to the product rule because there's two parts. So you do the derivative of the x first, which is 1, times the y unchanged, plus, right? Remember this? You take turns, plus the x unchanged times the derivative of the y, which is y prime. Derivative of y is derivative of x. See what happened there? So one more time. Whenever we're dealing with a function that has something inside, we have to multiply by the derivative of that inside. That's what the chain rule says. And so to take the derivative of that inside, we realize we do the product rule because it's two things multiplied. That means they take turns. The derivative of the x first is 1, y just sits there, x just sits there, derivative of y is y prime. All right. Now the other side, let me change up the other side. That root, you know what we do with those roots. We should have just made that a half power from the beginning, huh? Or 0.5. Let's do that. So that's a 0.5 power, and we're going to take the derivative of that whole side, right? Because a square root is a half power or 0.5 power. What happens? The 0.5 comes down. The inside stays the same at first, and you lower the power by 1 minus 0.5. Okay, but we're not done there because again, the inside is not a simple x, so the chain rule tells us we got to multiply by the derivative of the inside. So times, what's the derivative of the inside? What's the derivative of x first off? This is 1 minus, what's the derivative of 2y? The 2 just sits there. What's the derivative of y? Y prime. Okay, wow, what a mess. What a mess. This is indeed a mess. Okay, let me help you with how you need to look at the landscape here. This is all one term, meaning there's no pluses or minuses between them. This is one term, we call it. One term, because there's no plus minus. Whereas here's a plus. So these guys are separated into two terms. right? So let's just start with that side. That means, yeah, this is going to be a really bad one. So that means this whole 9 secant xy tangent xy is going to go boom and boom to hit this term and that term. It's going to get even uglier. 9 secant xy tangent xy times y, right? 1 times y is just y plus. And now this whole thing goes here. That's going to be 9 secant xy tangent xy times x times y prime. Okay, equals. Okay, now the other side. Um, yeah, this is just getting bad. Yeah, what see how this piece is to like a negative zero point 0.5 power? That's a negative square, that's a square root of the denominator. That's just a mess, is my point. We don't want to mess with that. Just leave that be. Take that whole term. See how this is one whole term. Wait, let me do that better. See how this is one whole term? Um, take that whole thing and go boom and boom. Distribute it through those parentheses. You might wonder, Mr. Ryan, why isn't this like two separate terms? Well, I mean, it is, but it has a weird old power on it. So I'm not going to separate it. You can't just do the power. You can prove that's not true with numbers. It's just weird and ugly. So I'm just going to keep it intact. I can't really separate it. It's ugly. Whereas this parenthesis here and this parenthesis there, they don't have any power on them, right? There's no power up here on this parenthesis, no power. So we can distribute through those parentheses easily. So, okay. So what do we get then? I'm running out of room like in big time. I'm gonna go. Here's the right side. 0.5 x minus 2y to the minus 0.5 times 1 minus, oops, right? Because it went times 1 minus, and now it's going to be that same thing, 0.5 x minus 2y to the minus 0.5 times 2y prime, 2y prime. That's the right side. Wow, this is ugly. Okay. 4 terms. So now, so that's the derivative of both sides, and that was terrible. Step 2. There's 4 terms. See how this term right here has a y prime, and this term right here has a y prime, and the other two don't, namely this guy and this guy. That's how you want to look at it. There's 4 terms there, and 2 of them have y prime. So you want to get those on the same side. So get the y prime terms, y prime terms on one side. So how do we do that? Well, I'm going to grab this whole whopping thing and I'm going to toss it over there. I'm going to grab this whole whopping thing on the right side. Oh, wait a minute. No, 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 no. I'm going to grab this whole thing and toss it onto the left side. That'll put both the y prime terms on the left side. So what do we have then? So then we have 0.5. It's negative here, so when it jumps to the other side, it'll be positive. X minus 2y to the negative 0.5 times, oh, by the way, look, 0.5 times 2, they're just going to cancel, right? Because half times 2 is just 1, they're gone. Let's just make life nicer and get rid of that. That's just 1. See that little step there, right? 0.5 times 2, you can just put this 2 out here with it. You can always move around the order of multiplying. Two halves is a whole, it's 1. Okay. Um, y prime. Okay, there's that term. Plus this term, because he stayed put, 9 secant xy. I know you're probably thinking at this point, this is unbelievable, Aaron. I know, this is calculus. This is why it has a reputation. Times x times y prime, right? That's that term right there. So they're both on the left together, equals, and now on the right side is this term, he stayed put. So it's 0.5 x minus 2y to the minus 0.5. He doesn't have a y prime. And then this guy is going to jump to the other side. So what if I can squeeze him in? He'll become minus because he's positive. Oops, he's positive over here. When he jumps to the side, it becomes negative minus 9 secant xy tangent xy times y. There we go. It's a little, that's not so good, is it? Let me try it again. Just trying to get this squeezed in here. Secant xy. That's just a terrible problem. Oh no, it blew it again. Trying to squeeze it in there. Tangent xy times y. Okay. Now, step 3. So these two terms both have y prime and the other terms on the other side don't. Factor out y prime and divide. You've seen this before, right? So these two terms both have a y prime. So prime in the front and y prime in the front. And I'm going to put a little parenthesis, and then it's going to be x minus 2y to the minus 0.5 plus 9 secant xy tangent xy times x. Right? That good? Now y prime could go, whoops, I missed it. Y prime could go boom, boom, hit this, it would go back to that and that, wouldn't it? Okay, the other side. 0.5 x minus 2y to the minus 0.5 minus 9 secant xy tangent xy times y. All right, we are so close. Divide, divide. Both sides by x minus 2y to the minus 0.5 plus 9 secant xy tangent xy x. So what do we do to one side? Yeah, no choice. Do the same thing to the other to keep them equal. This is high-level math science kind of stuff here, isn't it? It's a mess. Oh, all those little xy's, I'm growing weary of writing them. Times x. Okay, boom, boom. Y prime's alone after all that. Okay, now, that was awful. Okay, now we're supposed to plug in the point 81, 0. That's x, that's y, right? All right, let's do it. So 81, 0. X, that's y. So we'll get y prime on the left. So what I'm going to do is I'm going to plug in 81 for x. So that'd be 81 and 0 for y. 81 for x, 0 for y. 81 for x, 0 for y. 0 for y right there. 81 for x, 0 for y. 81 for x, 0 for y. 81 for x, 0 for y. 81 for x. All right. Wow. You can type that in. Let me show you how to make this easier. So this is effectively 0.5 times 81 minus 2 times 0 is just 81 to the minus 0.5, right? Minus, and now secant of 80, x times y, 81 times 0, that's secant of 0. See, what's the cosine of 0? So you can type that into your calculator. Cosine of 0 is 1, so this is just 1. And then tangent of 81 times tangent of 0 Oh, that's 0. And then y is 0 anyway. So that's all just gone to be 0. On the bottom, we've got 81 minus 2 times 0, so that's just 81 to the minus zero point 0.5 plus 9. Secant of 0, again, is 1. Tangent of 0 is 0. That's nice. And the x is 81, but that's all just gone in 0 also, because the tangent of 0 is 0. Sine over cosine. Hit it on your calculator, sine of 0 is 0. All right, so comes out now. You just hit the buttons on Desmos calculator if you want. I'm just kind of doing it by hand. All right, what do we got here? We got zero point 0.5. Now, you hit the buttons on this. This means it's a square root in the bottom. It's going to be 1/9 because it's a square root of point and it's goes to the denominator like that. Oh, actually, you know what? Yeah, let's do this. Here, let me make life easy for us here. It hasn't been easy. All we have left. Oh yeah, we can just cancel. What am I doing? I didn't even realize. We just cancel them. We don't need to mess around with them. It's zero point 0.5. So that's the slope, because that's y prime. So the slope is zero point 0.5. Go back and see if we get that right so far. So the slope is zero point 0.5. Yeah, a half. That's right. There's slope. So we got to find the rest of the equation. Okay. So that's good. That's encouraging, huh? We got that part right. So now we're going to use y equals mx plus b. And plug in the slope, 0.5 right there. X is 81. Y is 0. And we can solve for b. Half of 81 is 40.5. And then just jump this to the other side. Minus 40.5, that's b. So we got it. Y equals mx plus b. Y equals 0.5x because we found the slope is 0.5. B is minus 40.5. There it is. Is that what they got? Probably say 81 over 2. Yeah, same thing. Woo! That's something. So there we go. You're gonna need to practice that. I had to. I had to practice and practice and practice to get this kind of stuff down. There we go.